Hey, what's up everyone? My name is William and today we're going to be going over the different dynamic processors that are included in Logic. So first of all, I've just opened up a new session here and set up different audio tracks, one without any effects, and then each of the remaining 8 tracks I've set up with a different dynamic processor that we're going to be covering. So, dynamic processors, when we're referring to that, we're referring to, things such as compressors, limiters, deessers, expanders, and even noise gates. These are all different things that change the dynamic qualities of our audio signal when it's going through one of these corresponding effects. So the audio signal we're going to be working with today is called 70s Rock Piano 1. I just found it in Apple Loops. I searched for piano and I scrolled to 70s Rock Piano 01. This is the one we're going to be using. And then of course I just duplicated it to give us a little bit of a longer loop to work with. So, going right in, let's just first, before we move on to any of the effects, let's listen to what our audio signal sounds like without any effects on it. So that is what our 70s Rock Piano 01 sample sounds like. Of course, it played twice because I had it duplicated there. But let's jump right in. The first audio effect that we're going to be covering is the adaptive limiter. So the adaptive limiter is a very versatile effect when it comes to controlling the perceived loudness of our audio signal. And it does this by, taking the peaks of our signal and rounding them out. It rounds out and smooths those peaks in the audio signal, changing how the perceived loudness is. So first, starting off looking at this adaptive limiter, looking on the left side here, we first of all have 3 meters. These are, we can't change anything about these per se over here. We control the how the adaptive limiter works with the knobs over here, but this is a visual representation of what's happening with our audio signal. So this meter all the way on the left is our input meter, if you couldn't tell by the title at the very top there, and it tells us how hot our audio signal is coming into this adaptive limiter effect. Next we have this reduction meter, and of course these values are all in decibels. And the reduction meter tells us, however much our input is exceeding over 0 dB, it tells us how much it's reducing in order to, make sure that it's not peaking. It's smoothing out those peaks in the audio signal. And then the last meter we have here is our output meter, which tells us how loud our output is, how loud our signal is coming out of the adaptive limiter. So we get nice visual representations of everything that's happening here. As we're using it, you'll be able to see what's happening with the meters over here, and it's actually very easy to understand once you see it in play. Moving over to the right side of the adaptive limiter, we have 3 different knobs, and these are, what control how it's smoothing our peaks and things like that. So the first knob is very straightforward. It is a gain knob. It's an input gain knob. If our input's coming in a little too quiet or something like that, we can boost our input like this to allow the adaptive limiter to actually even be affecting the signal. Then each of these knobs also has a button underneath it that coincide with it. So when we're talking about the gain knob and the loudness of our signal, this DC offset button right here, it removes the DC offset of our signal, which that is essentially, when this is enabled, essentially is like putting a high pass on our signal, although it's not a high pass in a way where it is removing actual, elements of our sound, but it's taking out the very high frequencies, maybe some of the very white noise type of stuff that's kind of muddying up our signal, and that sometimes is introduced when using lower quality gear or hardware. So that's just what that button does. Typically it's a good idea to just leave it enabled. Right now I didn't mention, but I am using the factory default preset, and it is enabled on that. Next is the out ceiling knob. The out ceiling knob determines how loud the maximum output is, meaning whatever this is set to, our output will not exceed. By default, it's set to 0 dB, meaning our signal on this output meter will never go over 0 dB. Sometimes it's a good idea to bump it down to like -0.1 dB just to make sure nothing's distorting or anything like that. But this just determines our maximum output volume that's possible for our audio signal after going through our adaptive limiter. The button underneath the out ceiling knob is the true peak detection button. This just changes the essentially it changes the algorithm that's used to determine the peaks. Definitely, as you're using this, make sure when you're using this on your own, make sure you listen to the differences that you hear with the true peak detection. Sometimes with an untrained ear, it may not sound like anything's happening. But it just changes the algorithm of the peak detection and can change the how the adaptive limiter is working. The very last parameters are the look ahead knob and the optimal look ahead button. So the look ahead knob, this just determines how far ahead the adaptive limiter is looking for peak detection. As it's looking for peaks in the audio signal, this is how far ahead it's looking. It's pretty straightforward. This is just milliseconds, determines how far ahead it's looking. If you do a higher look ahead, it will add some more latency to your sound, so that's something to keep in mind. And the last thing to note is the optimal look ahead. This is just the optimum value that the adaptive limiter thinks that it should be at, what the look ahead should be at. You can just simply apply this value by clicking the button rather than having to change the value up here. But that's just something to keep in mind. It thinks that it should be at 20 milliseconds, and we can do that. The factory default had it set at 50, so I'm just going to leave it at 50. And also, changing certain parameters like, turning on the true peak detection mode, it actually changes the optimal look ahead that it thinks it should have to 30 rather than 20 what it was at. So that's just something to keep in mind. One last note before we kind of listen to what this is actually doing to our audio signal. The adaptive limiter is typically used on a master channel, after your audio signal has possibly gone through a compressor or things like that. It's used as a master channel effect, 90% of the time, just because it's good for controlling like the peaks of your overall track and make sure you get that perceived loudness that you want out of your track. But let's just go ahead and first of all listen to what our signal sounds like again without the adaptive limiter. Okay, so that's what it sounds like without the adaptive limiter. Now I'm just going to turn the loop on, and we're going to listen to what it sounds like with the adaptive limiter, and I'm going to adjust some settings here so we can hear the differences that are occurring as I'm changing these settings here. All right, so this is what it sounds like with the adaptive limiter. So as you could hear, it really made it seem a lot louder when in fact we still weren't even peaking over 0 dB. So, it's a very versatile tool to use. Definitely, you'll definitely be using the adaptive limiter when working on tracks. But as you could see, we could see the input coming in. As I turned up the gain, it started going over 0 dB, which is fine, but we don't want to have too much peaking over here, just because that'll start introducing distortion into our signal, which, I mean, again, it might be a creative thing that you want to try out, which definitely, go ahead and do that. There's some presets. I think there's actually a preset. Oh yeah, overdrive limit. That is actually a preset that purposely makes sure the signal has a distortion on it. By increasing this gain quite a bit, but then we saw the reduction happening. It was showing us that, and it tells us the value up here that it got to a maximum of 3 decibels of reduction. And then of course our output, and I tried to change the out ceiling. I hope you notice what was happening there. As I had it down to -2, it wouldn't cross -2 over here, and as I brought it up, it started getting closer to 0 dB on the output, because it was allowing itself to get that loud. But that sums up the adaptive limiter. The next effect we're going to be covering is the compressor audio effect. So the compressor is a very widely known effect. It's very popular, and it's very crucial that, as someone working in audio, that you completely understand how a compressor works. I know, starting out in audio for me, it was something I had a little trouble comprehending, but again, I can't stress enough the importance of understanding how compressors work, just because how, important they are in the field of audio. So, moving on to what the compressor actually does is it takes your audio signal, and as it's going through the compressor, what it's doing is it's reducing the dynamic range of your audio signal, as well as increasing the perceived loudness. So what that means is, we set a threshold when working with a compressor, and meaning that everything above that threshold is reduced in volume, dependent on how we set the compressor. Depends on how much it's reduced, and the lower things in the mix still we can still hear them very well, and it brings them up dependent on, again, on our settings. But a compressor, because it can do this, what it allows us to do is really make, key elements of our songs, of our tracks, make them really pop, but still keeps the, much quieter or softer parts, still very, prominent in the mix. It allows us to still hear those clearly in the mix. So, compressors are very versatile effects that are, again, like I said, I can't stress this enough, very, very important, and it's very crucial that you understand how to use these. So moving on to, the actual parameters of this compressor. So first of all, let's just look at the top here. We have, 7 different buttons here, and what these do is, in addition to change how our compressor actually looks, it changes the circuit type of our compressor, meaning, it's essentially just like different modes for a compressor. It gives us different tonal sounds and things like that. Next, moving on, we have this visual representation of how much compression is happening, and we also have this meter and graph button. Right now we're on meter mode, that's why it's darkened out like that, and it's the classic meter visual representation of how analog compressors represent how much compression is happening. And we can also go to this graph visual representation, which in my opinion is very good, especially for beginners, people that don't have much experience with compressors, just because it's in my opinion, an easier visual representation. On the left here we actually have a visual representation of our compressor's curve. We can see the curve of the compressor. Just for example, we'll get in depth into it. The ratio essentially determines how much compression is happening, and as we turn that up, we can see this curve, get much sharper as I turn that up, and much shallower as I turn that down. So just we get a actual visual representation of the compressor right here, as well as we're playing audio, we can see when the compressor is, actually, reducing the signal as it's crossing the threshold. And over here it tells us by how much it's reducing that threshold or that audio signal. Moving on to the left-hand side, this is the first thing that you'll probably be looking at when we're using this on an actual audio signal. This is our input. It tells us how loud our input's coming into the compressor, as well as we get an input gain. If it's coming in really quiet, we can turn it up a little bit before it goes through the compressor. And that's about it for that left-hand side right there. Next is the center section. This, again, is the main section of our compressor because it's where the actual compression is happening. So aside from our visual representation at the top here, we get all of these parameters that control how our compressor is acting on our audio signal. The first one is our threshold. This determines where the threshold is determines, when the compressor starts compressing our audio signal. A lower threshold will, capture more of the audio signal, send more of the audio signal to be affected by the compressor, whereas a higher threshold will, not catch as much. The ratio, again, I kind of briefly went over this. It determines how sharp or how shallow, the compressor is acting. An easy way to remember this was something I always got a little bit confused about, but this is an easy trick to remember. So we have this ratio right here, which says 1 to 1, 1.0 to 1. So what this means is, for example, I'll set it to 2. For every 2 decibels that's crossing our threshold, 1 decibel is coming out. So we can, it kind of helps us understand a little bit better about what this ratio actually means. So that's just an easy way to remember. Typically when working with a compressor, you're not going to use anything over 10 unless you're trying to use it as a limiter. But, Logic has its own limiting effects, so there's no reason to really use the compressor as a limiter. I typically keep it around 2 to 3. That's a good area, in my opinion, to start at for your ratio. Next, though, is the makeup gain. This just determines how much gain is happening after your signal is going through your compressor. It gives us a visual representation over here by how high or how low this curve is on our graph over here. Next to the this makeup gain knob, we have the auto gain options. The auto gain options help, for the compressor to automatically, add a makeup gain to our signal. So, we get 3 different options here, and again, you can see what's happening with this visual representation. It just determines, it's an automatic gain, just some presets, but it just automatically adds some makeup gain to our signal. Next, moving on to the bottom over here, we have a very important knob, which is called knee. Now, I feel like this knob is overlooked a lot, but especially when getting really in depth with using a compressor, it's very important. So when we're looking at our visual representation up here, we can see that this is coming up, and then this is where the this is where the ratio kicks in, and it starts compressing. 3 to 1 is what we have it set at right now. So we can see that definite sharp curve that's happening. So the knee determines how sharp or how shallow that point is. So, at 0, it's a very sharp, it changes instantaneously from the regular signal to the signal that is affected by our compressor, the ratio. So as we turn this up, what's happening is it's smoothing it out. And as you can see, as it's all the way up, it's a very smooth curve. So, what that means is, instead of as soon as you get to this point, it compresses at 3 to 1. What it means is, even down here, it's starting to compress slightly, not a lot, but slightly. And then by the time you get all the way up here, you're compressing at 3 to 1 ratio. So that's just something to keep in mind when messing with the compressor. Definitely adjust the knee to get some different effects happening there. The next two knobs are again quite important, but I feel like they're looked over. The attack and release. This determines how fast the compressor acts when the audio signal crosses our threshold. If you have a really slow attack, it's going to take a little bit to actually start compressing after our signal crosses a threshold. And again, by takes a while, I mean 200 milliseconds. Obviously, in the big picture, 200 milliseconds isn't a ton, but when working with compressors, that can mean a huge difference. So that's something to keep in mind. Next is the same thing, except it's release time that determines how long it takes for the compressor to stop compressing. Once our audio signal is back under our threshold, how long does it take for the compressor to stop compressing our signal? So very similar to the attack knob. It's just we're talking about the release instead of the attack. Very basic ADSR type stuff. Things that we should be at least semi-familiar with. And then next we have this auto button, which just is kind of an auto release, which kind of helps determine the release of the compressor. Again, it's kind of similar to the auto gain for the makeup knob, but it's just an auto knob for the release, and we just have an on or off option. There's no different settings for that. So moving on to the very last section is our output settings. We have this limiter option, which we can turn on a limiter and determine the threshold of the limiter, which determines where our signal is being limited at. Typically, you'd leave it around 0 or so for the limiter. But next you have distortion, which if you want to add some type of distortion to your audio signal, you can do that. And then we have our mix right here, which this is, a dry wet knob essentially. It mixes between our input signal and our output signal. That's why it's labeled input and output. Left is input, right is output. Typically, you want to have a compressor 100% wet, unless you're doing something, different and creative, then, definitely they give you that option. But the last knob over here is the output gain, which is very similar to the input gain, except it's just gain that's added in the output. If after your compressor, or after your signal is being affected by the compressor, if it's coming out a little quiet and after you're going through the limiter and everything, you can boost up that signal a bit if you need to. Talking about this last section though, there is two options for this last section. So if we're using this as a regular compressor, we just want to keep it on output. However, we can use the compressor as a sidechain effect to, get the signal from somewhere else to control the compressor of our audio signal, if that makes sense. When listening to a lot of electronic music, the very, the effect where the kick drum comes in and after the kick hits, you can hear the chords more, and then the chords go out. That's a side chaining effect. And then these are just different options for that, that mode. So we have the detection type of our compressor, whether it is a max or a sum or peak or RMS modes. Then we have the filter, that we can control over here. And we just have some basic filter options that determine, the frequency of our filter, what type of filter we have, the Q of that filter, as well as the gain of that filter. So again, those are just different options when working with the compressor. Now, I know that was a lot to cover, but let's just listen to what our audio signal sounds like without our compressor. Okay, now we're going to listen to what it sounds like with our compressor, and I'm going to turn that loop on so we can adjust it slightly as we're listening. So first what I'm going to do actually is I'm going to change it to recall default before we actually start adjusting the parameters, just so we can start on the same page. So let's listen to that again. So that's what our signal sounds like with the compressor. Again, let's just listen to compare. So this is without our compressor. Now with our compressor. So, obviously, depending on what you want to do, you wouldn't do exactly what I did with your compressor. It sounds like it's compressing a little bit too much right now. You can hear a lot of the white noise and things coming through. But again, it's a lot of creative, creativity that's involved when using compressors and any of these effects. I mean, as there is, some rules that should be followed, meaning, you shouldn't be using a ratio of 30 on your audio signal or something like that. It's still, I mean, this is audio. There's no, for the most part, there's no right and wrong. It's just, trying things out and trying them differently. So moving on, though, the next effect that we're going to be covering is the deesser. So the deesser effect is a very important effect to use. It's mainly used for things such as vocals, as well as hi-hats and things like that. Because what the deesser does is it's actually a filter-based compressor, meaning we get two graphs here. We get a detector area right here, as well as a view for the detector, and a suppressor suppressor parameters here, as well as the view for the suppressor. So what this means is we set our detector by setting the frequency, and then we determine the sensitivity of our detector by using this percentage, to change the sensitivity of that. Also, real quick, just so we can hear what it's doing, this monitoring mode changes what we're listening to, whether we're listening to the detector, the suppressor, or the sensitivity. We're going to listen to the detector right now. Turn this on, and now since we're monitoring our detector mode, what this means is we'll just hear what's being picked up by our detector. So that's the area right there. I'm going to use this one since there's a lot of white noise and things like that. And what we're going to do is then we're going to listen to our suppressor, and this is going to, and again, I'm just raising the sensitivity and strength of these just so we can hear the very extremes of this. The frequency of the suppressor is determined by this, which determines just where the frequencies are being affected. Again, this is just like a compressor; it's just frequency based. The detector is it's like setting our threshold, except it's only for a certain frequency range, and then our suppressor is where it's compressing only in a certain frequency range. And the strength, determines how much it's compressing and things like that. So now let's listen to the suppressor and what it's suppressing. So this is what our signal sounds like as it's suppressing all of these frequencies. So if I turn this all the way down, it would sound just like the normal sample. So that's what that does. And then the last parameter we have is this smoothing slider, which just determines, how smooth it sounds, when it's actually compressing these frequencies. To the untrained ear, it's kind of hard to hear what a deesser is doing, but it's reducing presence. It's just a very useful tool once you know what you're doing. It's just a frequency-based compressor. It's used mostly to get rid of like sibilance in vocals and things like that, if the S's are very harsh and things like that. But we're gonna obviously use it on this piano just so we can hear what's happening in comparison to the other effects. So first of all, let's listen to what our audio signal sounds like without our deesser. I'm also going to make sure I change this monitor mode to off, so we're not listening specifically to a certain either the detector, the suppressor, or the sensitivity, just so we can hear what's happening with our deesser. So again, first let's listen to what our deesser is doing by listening to our audio signal without the deesser activated. Okay, so now let's listen to what our audio signal sounds like with the deesser. And I'm actually going to loop the audio signal a couple times and turn on and off the deesser to, allow you to possibly hear the differences that are occurring. Definitely use the deesser. Ask your mentor about it if you're, struggling to understand what's happening here. But let's just get ready to and listen to what it sounds like with our deesser. Definitely listen for the white noise that's happening. It's a lot less prominent, when we have the deesser on. So again, let's just take another listen without. So that's the differences that are occurring with our deesser there. Next, though, let's move on to our next dynamic processor that we're going to be covering, which is the enveloper. So the enveloper is pretty straightforward. It's nothing too complex compared to some of the other dynamic processors. I think it's one of the more simpler dynamic processors to understand. It simply changes, how our attack and release of our signal sound dependent on whether or not it crosses our threshold. So everything that crosses a threshold is affected. The attack and the release is adjusted, according to what we have set here. So right now, this is the factory default preset. We're going to open up the add tail effect so we can hear the differences it's doing. But simply we adjust our threshold to, everything that, surpasses our threshold will be affected by our enveloper here. On the left side here, we have our gain for our attack. So right now for the add tail preset, it takes the attack gain down by 80%. And then for the release gain, we have plus 90%. That gives us that extra release tail there. Next we have the time to adjust our attack and release times. That's what these two knobs are doing. The look ahead, that just determines how far ahead our enveloper is looking ahead to, determine whether or not the signal is going to be crossing our threshold. As you increase the look ahead, some latency will be added to your signal. And then the last parameter is the output level. Very straightforward, very easy to understand. So first, let's listen to what our enveloper is actually doing by listening to our audio signal without the enveloper activated. So that's what it sounded like without the enveloper. Now with the enveloper, using the add tail preset. So you can hear the interesting, qualities that it, added to our signal to change how our attack and release sounded. The enveloper is a very cool tool to use to shape your sound a little bit more, to have a little bit more control over it. But it's a very straightforward, dynamic processor. That about wraps up the enveloper. The next effect that we're going to be covering in this video is the expander dynamic processor. So the expander is very similar to the compressor in the fact that the compressor, reduces the dynamic range of our audio signal, where the expander actually increases the dynamic range of our audio signal above a certain threshold, of course. The expander looks much more simple than the compressor, and that's just because we don't have as many parameters here. But let's just go over some of the parameters real quick. I am going to load up the more punch preset, though. That's the preset we're going to be using on our audio signal. So let's just look at what's happening with this preset. So first, over here on the left side, we set our threshold. Everything that surpasses this threshold is going to be affected by our expander. And then this just determines the mode that it is detecting, our signal at. Next, we have the attack and release knobs. These knobs determine, how fast our expander is acting, and then how slow it's, or how long it's taking to stop affecting our signal. So that's what these two knobs do. Very similar to some of the parameters we've seen in the compressor. Next, we have the ratio and knee sliders. The ratio, again, is the same as the compressor, where it determines, how many decibels over results in 1 decibel coming back. So for this preset, we have every 0.6 decibels that crosses the threshold results in 1 decibel going to the output. So that's just something to keep in mind. It's expanding, it's not compressing. Whereas the compressor, we're looking at ratios more of 2 to 3 for the average. In the expander, the less than 1 is the average ratio for the expander. Next, we have the knee that just determines the curve of our expander. It was set at 0.3. I'm just going to leave it there. And the last two parameters are, of course, the gain slider here, which just determines our output gain. And then we also have an auto gain feature where, if we wanted to automatically detect our signal and automatically adjust the gain, we can enable that to do so. So let's just jump right into it and listen to what our signal sounds like without our expander effect activated. Okay, now listening to what our signal sounds like with our expander activated, and we're using the more punch preset here. So that's the differences. You could hear some more liveliness added to our sound, some more punch, it sounded like. I mean, that is the preset's purpose. But that about sums up the expander. Next, we're going to be moving on to the limiter dynamic processor. So the limiter effect is another effect that is very similar to the compressor. This effect also looks quite similar to our adaptive limiter, except we just get some different controls over the adaptive limiter compared to the limiter. So the reason, our limiter is very similar to our compressor yet again, because the compressor, once a certain threshold is passed, the compressor will reduce the dynamic range of our signal after, everything above the threshold will be reduced dynamically. Where the limiter, it will limit the level of output to that threshold. So, our volume will not surpass that threshold that we set. So, looking at our limiter here, we're looking at our factory default preset. We get 4 knobs and then 1 button right here and then a drop down box right here. So going into it, first we have our gain knob. Our gain knob is just input gain. If our signal is coming in a little bit quiet, we can boost the gain. If it's coming in a little bit loud, we could take it down. And we have a range of -20 to +20 decibels there for control. Next, we have the release knob. The release knob, changes how our limiter acts, how long it takes for the limiter to stop affecting our signal. So I'll show you some differences there as we are affecting our signal with the limiter. But 2 milliseconds means our limiter will stop limiting very fast once the threshold is no longer being passed, and the higher the release time, the longer it will take to release it. Next is our output level. This essentially is our threshold. This is what we don't want our signal to pass. So by default, it's set to 0 dB. We can actually set it to +1 or all the way down to -10. We have that entire range. So this is the threshold of our limiter. Essentially, it's saying that our signal, no matter what, is going to pass. It's not going to pass this level. So it's never going to go over 0 dB while it's set like that. Next is the look ahead, which just determines how much time our limiter has to look ahead and detect peaks in our signal. Again, the more look ahead time we have, it will add some slight latency. But from a standpoint of 0 milliseconds to 10 milliseconds, we won't even notice that. That's not going to be noticeable at all. The last two things to cover is the mode. This just changes the mode of our limiter. Definitely experiment with those two settings. And then next is the soft knee, dependent on when looking at a compressor or things like that, how we adjusted the knee, and it had the rounded curve for our, compressor. It's the same concept here, whether or not we want that soft curve happening or we want a sharp curve. So again, just definitely experiment with that. Try the different options there. But let's listen to what our signal sounds like without our limiter activated. So that's what our signal sounded like without our limiter. Now we're going to just activate this limiter. I'm going to turn on the loop, and we're going to loop it a few times as I adjust some settings in the limiter here. So that's what our signal sounds like with the limiter. I was changing the settings. I hope you noticed as I was changing the release, it was, taking a lot longer for the limiter to not be reducing our signal. As I changed the output level, it wouldn't, I changed it all the way down to -10 just so we could hear the difference, and it wouldn't cross that -10 dB threshold. But yeah, that's about it for our limiter dynamic processor. Next, we are going to be moving on to our multipressor dynamic processor. So the multipressor is a very versatile dynamic processor. It's something that you definitely will want to familiarize yourself with. What it is it's actually 4 compressors and expanders built into one effect. And the reason there's 4 of them is because we can actually determine the frequency bands which each compressor is affecting. For example, we have 4 bands, and the first compressor, compressor 1, which we can turn on and off here, is affecting everything from 160 hertz and below. And we can adjust the crossover values right here. I'm not going to go too in depth with how this works exactly, just because we've already gone over compressors, we've gone over expanders. This is literally just 4 in 1, and we can control how each frequency band is compressed individually. So the main things that I want to point out again is there are 4 bands. We can set the crossovers of these bands by changing these values here, so it determines what frequencies are being affected. The next thing is we have makeup gain for each of the bands individually that we can adjust. Over on the right side, we have an auto gain feature that we can adjust, as well as our look ahead over here. And then, each of these bands are set up the exact same way, just dependent on, what frequencies they're affecting based on what we've set up here. Each band has the power button, which is very important to remember. Very simple, but, you can actually click these on and off. So if you only want, 3 bands or 2 bands or 3 bands, you can do that rather than having all 4 activated. So next we just simply have this threshold for our compressor that we set, the ratio for our threshold. Then we have peak/RMS. Lower values are more like peak detection, whereas higher values are more like RMS detection for our peaks. Then we have the attack and release of our compressor/expander, how it's affecting that. Then we have the expander threshold. So everything, you know, above this threshold will be expanded, and we have the ratio that we can adjust and the expander reduction that we can change here. And of course, you know, if we have a ratio of 1 for the expander, for example, that's not going to affect anything because it's going to give us 1 to 1. Every 1 decibel is going to come back 1 decibel, so there's going to be no change. Same thing with the compressor. You know, if we only wanted to do expanding, we could just set our compressor to a ratio of 1 and then affect our expander by changing the ratio of that. So you know, that's about it, honestly, for the MultiPresser. We also have our gain over here that we can determine, but let's just look at the final hip hop compressor preset, and that's what we're going to be listening to, you know, and how it affects our audio signal. Again, it's actually pretty straightforward. It looks a lot scarier than it actually is. It's just 4 different compressors built into one. So let's listen to our signal without the MultiPresser activated first. So that's what our signal sounded like without our MultiPresser activated. Now let's activate our MultiPresser, and we're using again the final hip hop compressor preset. So those were the differences you could hear. You could see the signals in the different frequency bands like so. But that about sums up the MultiPresser. I know I didn't go super in depth with this, but again, it's because it's all concepts we should be familiar with. The only thing that's different is the crossover adjustments, which, you know, again, it just determines what frequencies each compressor is affecting, and we can determine, you know, what compressor is linked to which frequency band by just looking at the numbers up there. Okay, so moving on to our next and final dynamic processor that we'll be covering, which is the noise gate. So the gate is a very interesting effect and very cool effect to use to remove unwanted noise that is low in your audio signal. And so what the gate actually does is, you know, it uses a threshold to determine whether or not it should be reducing the signal. So for example, everything right now that is crossing our negative 50 decibel threshold, everything above that will be unchanged. It will not be affected. It will sound normal to us. Everything under negative 50 decibels on our threshold is going to be reduced by negative 100 decibels. So, you know, everything that's much lower in our mix, the gate will try to take out. So that's just, you know, it's a very cool tool to use when working with audio, especially with audio that has some unwanted noise and things like that. We're going to adjust this and change how it is so we get, you know, so we can hear the differences as what the threshold's doing. But before we get into that, let's just move on to what all these parameters are doing. First, we have these 3 knobs here. We have the attack, hold, and release knobs. The attack just determines how long it takes to fully open the gate, meaning, you know, how long it takes to fully hear our signal. Hold determines how long the gate is held open after the signal crosses below the threshold again. And then the release determines how long it takes to fully close the gate once it is, you know, once it's held it for a certain amount of time. It'll take, you know, 10 milliseconds to completely close our gate again. And when I'm saying opening and closing, you know, the gate is open when we can hear our signal. The gate is closed when we cannot hear our signal. So next we have this activity button, which just tells us whether or not our gate is open. At the very bottom, we have these 2 sliders. This top slider right here, it determines, you know, the, I guess, the leeway room for our threshold, meaning, you know, if there is a signal that's happening right around our negative 50 decibel threshold and it keeps crossing our threshold and, you know, getting away from it or going beneath it, you know, this will give us some leeway room. So the -3 decibels underneath the threshold will still come through a little bit, just so we don't have our gate constantly opening and closing if our audio signal is right around that threshold. Next, we have our look ahead, which we can change here. We get a maximum of 20 milliseconds, a minimum of 0. And then our last parameters here are our sidechain filter parameters. So it's called sidechain because this is just talking about what signal is triggering our gate. Essentially, it's not necessarily needed to be. It doesn't necessarily need to be a sidechain. For example, when our sidechain selection up here is set to none, it's just talking about our main signal, the signal that is affecting our gate. And we get these filter options, this high cut and low cut, to change how our gate is opening and closing. And we can do that, a quick easy example is if we only want our gate to open when high frequencies pass -50 decibels, we could raise this low cut, and I'm going to raise this threshold a little bit, say like 25 maybe, -25, that might be good. And then let's just listen to what it's doing to our signal. I may have to adjust it a little bit as it's happening, just letting you know. But let's just listen to what's happening. So lower this. So it just gives us some different effects with our noise gate. And we also have this monitoring button if we want to just listen to what our filtered signal sounds like. So again, it's using this affected signal to control our gate. But that is a quick overview of what the noise gate does. It's definitely a very useful tool. Obviously, we can listen to real quick what our noise gate sounds like, or what our signal sounds like, excuse me, without our noise gate activated. So let's just listen to that real quick. And now let's listen to what our signal sounds like with our noise gate activated. So that is what our noise gate did. Obviously, if we really try to get rid of the unwanted noise, lower in the audio signal there, we would set this a little more accurately to that. I just set it to, give us a clear distinction as to what's happening. You can hear the signal cutting in and cutting out, the gate opening and closing. So that was just a very obvious example I gave us there. Obviously, you could adjust that accordingly to change how it sounds. But that about sums up that effect and this video. I hope you learned something. I know that was a lot to cover, a lot of dynamic processors. It's very important that you understand these, though. These are, very important tools when it comes to audio. So I hope you, again, learned something. Again, my name is William. Thank you for watching.